This lecture is on doing multivariate correlational research. This follows Chapter 9 in the Morling text. After hearing this lecture, you should know why simple bivariate correlations are not sufficient for establishing causation. You should be able to explain how longitudinal correlational designs can establish temporal precedence. You should be able to explain how multiple regression analyses help address internal validity, which is the third variable problem. Describe the value of pattern and parsimony, in which a variety of research results support a single parsimonious causal theory, and then explain the function of a mediating variable. And I would add be able to differentiate a mediating variable from a moderating variable, as well as from a third variable. All right, so a multivariate design is one that involves more than two measured variables. So multivariate designs include longitudinal designs, but the key is that there are more than two measured variables, often thought of as more than two predictor variables. So with a bivariate design, we had one predictor and one outcome. With a multivariate design, we've got more than two. So usually, at a minimum, a multivariate design would be two predictors and one outcome. And so multivariate design will allows us to get closer to making causal conclusions than bivariate designs do. So to review what it takes to make a causal conclusion, there's three criteria that we need to establish. The first is covariance. So is there a relationship between two variables? That's the criterion of covariance. The second is temporal precedence. Does one variable cause the other? And then the third is internal validity. And what we want to ask with correlational research is whether there's a third variable that might explain the relationship between the first two variables. That is, the reason why we see a relationship between our predictor and our outcome is due to the presence of some third variable or some nuisance variable. All right, so we want to be able to rule out a third variable, and that helps us establish internal validity. All right, so let's review longitudinal designs, because a longitudinal design will help us provide evidence for temporal precedence. It does this by measuring the same variables in the same people at several different time points. So this is often used by psychologists to help get closer to causal claims. So longitudinal designs produce three types of correlations: cross-sectional correlations, autocorrelations, and Crosslag correlations. We're going to look at each type of correlation separately. And so to do so, I'm going to share an example that was in the chapter, and this was a study by Brummelman and colleagues that investigated the relationship between parents praising their kids and the amount of narcissism in their children. So the researchers contacted the parents and the kids at 4 different time points, and each of these time points were 6 months apart. The kids completed measures of narcissism. And so, for example, they answered questions like, kids like me deserve something extra. So it's getting at this idea that they're little narcissists. They think that they're special and kind of the center of their own worlds. The parents completed measures, what the researchers called overpraise, the amount to which they provided like more than the usual amount of praise. And so parents completed questions like, my child is more special than other children. And so they were interested in trying to establish a relationship between the extent that parents gave their kids too much praise and narcissism, childhood narcissism. All right, so this example will just help us understand the difference between these three different correlations. Okay, so the first type of correlation that these designs can produce is a cross-sectional correlation. We can think about a cross-sectional correlation as being a slice in time. All right, so a cross-sectional correlation is whether or not two variables which are measured at the same point in time are correlated. So this particular study would yield 4 cross-sectional correlations. The correlation between overvaluation or kind of overly praising one's kid, as well as their kid's narcissism at time 1, at time 2, at time 3, and at time 4. So basically 4 cross-sectional correlations. These are the same as the bivariate correlations we've already learned about. And in this particular design, gets those at each of the 4 different time points. If the study only had 2 time points, time 1 and time 2, there would be 2 cross-sectional correlations. So in terms of our criteria for causation, what a cross-sectional correlation can establish is covariance. In other words, it can establish a relationship between overvaluation and narcissism, but it can't establish temporal precedence, that is, which comes first. There's still the directionality problem. So is it the case that a parent overvaluing their child, thinking that their child is so special, and then presumably like heaping a bunch of praise on the kid, is that the thing that causes the child to be more narcissistic? Or is it the child having an overinflated sense of their own self-worth, okay, the child being narcissistic, that comes first, and then the kid acting in a way to influence the parent, so that the parent says, wow, my kid is so great because my kid is telling me that they're so great. So with a cross-sectional correlation, there's a directionality problem. We can't establish temporal precedence. We don't know which comes first. A could cause B, but B could cause A. We don't know. Okay. Now, an autocorrelation is the correlation of each variable with itself across time. So, for instance, the researchers were able to ask whether mother's overvaluation at time 1 was associated with their overvaluation at time 2, at time 3, and so on. They were also able to ask whether a kid's narcissism at time 1 was associated with narcissism scores at time 2, time 3, and so on. So this is really, an autocorrelation is really a correlation of a variable with itself. And this allows us to establish test-retest reliability. Okay, so an autocorrelation can be important for establishing construct validity because it allows us to establish whether a measure is reliable, that people generally have a similar score from time 1 to time 2 and from time 2 to time 3. But it doesn't address the relationship between the predictor, in this case parent overvaluation, and outcome, in this case child's narcissism, because we're not looking at correlations between what is conceptualized as the predictor and the outcome. Okay, so it's really the Crosslag correlation that is important here. A Crosslag correlation is a correlation of the degree to which an earlier measure of one variable is associated with a later measure of the other variable. Okay, so it's an association between an earlier measure of one variable, in this case overvaluation, and a later measure of another variable, in this case narcissism. So what you can see here is a Crosslag correlation between mother's overvaluation of their child at time 1 and then the extent to which that is related to a child's narcissism at time 2. Recall that children completed questions and questionnaires. So this is a child's evaluation of themselves. So what we're able to look at with these cross-lag correlations is the extent to which a variable at time 1 is related to a variable at time 2. So we can see that there's these 3 cross-lag correlations between the mother's overvaluation at a previous time point and their child's narcissism at a later time point. And so researchers are most interested in these cross-lag correlations because they help establish temporal precedence. And so in the example that we see here, the cross-lag correlations are able to show how strongly mother's overvaluation at an earlier time point is correlated with a child's narcissism later on. What's interesting is that you can also compare and see how strongly a child's narcissism at time 1 is correlated with a mother's overvaluation later on. And in this example, what they found in the study was there was a non-significant relationship between a child's level of narcissism and the extent to which mothers overvalued them at a later time. So there's 3 possible patterns that you can get from a longitudinal design like this, which is also called a cross-lag study. What this study did show was that parental overpraise, in other words, overvaluation, at earlier time periods was significantly correlated with child narcissism at later time periods. So this pattern, the pattern that is shown in this figure here, is consistent with the argument that overpraising one's child leads to increases in narcissism over time. So you can make a causal argument here that it is the mother's overvaluation that leads to an increase. Notice the causal language. Now keep in mind, the study didn't, but could have, shown the opposite result. That narcissism at earlier time points was significantly correlated with overpraise later on. So that pattern, which they didn't find, but it would have indicated that childhood narcissism comes first, which leads parents to change or adjust the way that they're praising their child, or basically leads the parent to value them more and give more praise. A third possibility, I suppose we could say that there's 4, but let's say that a third possibility is that the study could have shown that both correlations are significant. That is, overpraise at time 1 could predict narcissism at time 2, and narcissism at time 1 could have predict overpraise at time 2. If that had been the case, it would mean that excessive praise as well as narcissistic tendencies in a child are kind of mutually reinforcing. So they can kind of like build on one another or increase one another. I spoke to a 4th possibility. You could get non-significant results in both cases, like both sets of cross-lag correlations could be non-significant. Okay, so the right pattern, the take-home here is that the right pattern of cross-lag correlations can help establish temporal precedence in being able to establish that variable A comes before variable B, and in this case, overvaluation is the cause of narcissism. And the researchers were able to make that causal argument because the pattern was that overvaluation at time 1 was associated with narcissism at time 2, but not the reverse. Okay, it wasn't the narcissism leading to overvaluation. So this establishes temporal precedence by addressing the directionality problem that happens with just simple bivariate correlational research. And if we only would have had a cross-sectional correlation. Okay. So longitudinal designs can provide some evidence for causation, by fulfilling our three criteria. So first, there's covariance. So when there are correlations between the variables, you've got covariance. And so if you find significant correlations, that first criterion is established. A longitudinal study can also establish temporal precedence, particularly if the pattern that you're looking for is established. So if one of the Crosslag correlations is stronger than the other, or if one is significant and the other is not, it moves us closer to figuring out which variable is the cause of the other. It is possible that longitudinal studies can establish internal validity, but only if third variables are measured and ruled out. Okay, so in this particular case, in the research study between parents' overvaluation and child narcissism, there could be third variables lurking out there that were not necessarily measured and ruled out. One possibility of a third variable would be the family's socioeconomic status. That is the amount of education and income that the family has. So you can have more educated and well-to-do families and less educated, less well-to-do families. So it could be the case that more affluent parents overpraise their kids, and these kids might think that they're better than other kids. So in that case, there's socioeconomic status that operates as a third variable because it is the true cause of both overvaluation as well as narcissism. Okay, so in the study that we just reviewed, covariance and temporal precedence were established, but internal validity is still an issue. So it doesn't truly meet all three criteria of causation. So while we're moving closer to a causal argument, we're not quite there because of the third variable problem. Now you might just ask, why not just do an experiment? Why mess with these longitudinal designs? They seem cumbersome. Well, there's several reasons. In many cases, participants can't be randomly assigned to a variable, and that's one of the key features of an experimental design, and a key feature for establishing internal validity is the random assignment to condition. So in this case, researchers couldn't manipulate the personality traits of the kids. They just needed to measure whether or not children had a high versus low level of narcissism. Parents also can't be randomly assigned to a parenting style. So that's a variable that just kind of naturally exists in the world. It would also be unethical to assign some people, especially children, to some sort of a condition in which they received a certain type of praise, right? So if you wanted to say like, well, could you turn your child into a narcissist? Let's do an experiment where you randomly assign some parents to praise their kids or overpraise their kids, and some parents to not do that. Well, that'd be an unethical thing to do, especially if you thought that that would turn a child into a narcissist. So for several reasons. One is that it is not possible or impractical to randomly assign to conditions. And then second, it would be unethical to do so. It's not just so simple as doing an experiment. So we have to measure variables as they naturally occur in the world, but still attempt to make a causal argument. So one thing that will help us do that is to get at this third variable problem. And so there's statistical techniques that allow us to address third variables. So this statistical technique is called multiple regression. It is sometimes called multivariate regression, and this helps address questions of internal validity by ruling out third variables. All right, so let's take a look at a second example. And this is based on an actual research study that found a link between watching sexual TV content or watching TV that had sexual content and teenage pregnancy. So what you can see in the graph here is a bivariate correlation or a relationship between exposure to sexual TV content and the risk for getting pregnant. Specifically, the researchers in this study asked teens to report the type of TV that they watched based on 23 popular TV shows, and then the researchers coded the shows for sexual content, like whether there was sexual intercourse, whether there was passionate kissing, etc., as well as how many scenes contained this content. So they were able to come up with a measure of the extent to which teens were being exposed to sexual TV. They also asked girls if they had ever gotten pregnant and boys if they had ever gotten a girl pregnant. So they were able to come up with a measure of pregnancy risk. So what we see here is that in the bivariate correlational study here, the two variables were positively correlated such that higher amounts of watching sexual content were associated with a higher risk of pregnancy. However, what we need to ask here is whether there are any third variables that could be responsible for this relationship. For example, you could ask, well, these are teenagers, what types of parenting do they have at home? Like, if you've got strict parents probably won't let you watch TV that is sexual in nature, and there's probably more rules like curfews and, having to tell your parents who you're spending your time with. So that might drop pregnancy risk. Alternatively, parents that are, either absent or, aren't very strict and don't have a lot of rules, might not care what their kids are watching on TV, and might not be really keeping close tabs on their kids. So both of those things might mean that there's more exposure to sexual TV as well as a higher pregnancy risk. Okay, so the short of it is that there's third variables, but there's many other things like the total amount of time of watching TV of any kind. There's the age of the teens. So a 13-year-old and a 19-year-old are quite possibly going to have much different risks for pregnancy. And 13-year-olds versus 19-year-olds watch very different things on TV as well. So age is a third variable that's necessary to consider. So that's what a multiple regression will allow us to do, is consider the influence of other variables. So age is one of those variables that we would really want to consider when thinking about the relationship between exposure to sexual TV and pregnancy risk. And so in multiple regression, the terminology that we use is that we want to control for age. Control means we want to hold constant. And so when conducting a multivariate design, the relationship between two variables could still exist when controlling for another variable, or when holding constant or taking into account another variable. All right. So why would it be important to control for age? It could be because the sexual content that teenagers watch on TV, or the amount of sexual content that teens watch on TV, and pregnancy risk are correlated because older teens are both more likely to watch more mature shows and are more likely to be sexually active. So in this case, all three variables are correlated with one another. Viewing sex on TV and getting pregnant are correlated, as we already determined, but watching sex on TV and age are also correlated, and age and pregnancy are correlated too. So what we want to know is whether this third variable that is correlated with both the original variables, it can account for the reason why we see a relationship between sexual TV content and pregnancy rates. And so to be able to answer this question, you have to see what happens when age is controlled for. So you can kind of think of controlling for in terms of proportions of variability. After the relationship between pregnancy risk and age is taken into account, is there still some proportion of variability in pregnancy risk that can be attributed to exposure to sexual TV content? So one possible outcome of controlling for age is shown in this graph. What we have here is that there is still an overall relationship between exposure to sexual TV content as well as pregnancy risk, even within the three subgroups: age 16, age 18, and age 20. So if you just kind of like let your eyes focus on the 16s, what you can see is that there appears to be a positive relationship between sexual TV content and pregnancy risk among the 16-year-olds. There also seems to be that same positive relationship among the 18-year-olds, and there also seems to be that same relationship among the 20-year-olds. So in this case, age is not a third variable. It's not a problematic third variable, because even when taking in age into consideration, we see that there is still a relationship within each of these age groups. What would it look like if age was a third variable? Okay, it would look something like this. What we can see here is that when you look within the 16-year-olds, there's no longer that positive correlation between exposure to sexual TV content and pregnancy risk. Looking within 18-year-olds, no relationship. Looking within 20-year-olds, no relationship. So it's true that 20-year-olds are more likely to watch more mature TV, and on average, they're also more likely to have a pregnancy risk. In contrast, 16-year-olds are less likely to be exposed to sexual TV content, and they have a lower pregnancy risk. So therefore, we can say that age is a third variable because it is responsible for the relationship between exposure to sexual TV content and pregnancy risk. In other words, it's not the actual watching of the TV that causes the pregnancy risk. Age is the third variable. All right. So how would this look in a research article? So we use the statistical technique of multiple regression to describe the relationship between pregnancy risk and sexual TV content while controlling for age. And so this is a regression table that you might see in a journal article. And so here's some basics here. The statistic that is being reported is a beta. This is another word for a regression coefficient. Okay, and so the beta value, you see a beta value for each of the predictor variables. Exposure to sex on TV is a predictor, and age is a predictor. Beta is similar to a correlation. A positive beta indicates a positive relationship between that predictor variable and the criterion variable. Criterion is another word for outcome. And it tells you whether there's a relationship when the other predictors have been statistically controlled for. A negative beta reflects a negative relationship when other predictors have been controlled for. And then a beta that is 0, or that is not significantly different from 0, suggests that there is no relationship between a predictor and an outcome when other predictors are controlled for. Okay, so there's several similarities between beta and then the correlation coefficient. The first is that a beta will tell you the direction of the relationship, either positive or negative, depending on the sign. Okay. The other similarity is a beta will tell you the strength of a relationship, very similar to a correlation coefficient. So the closer to -1 or to +1, the stronger the relationship. The closer to 0, the weaker the relationship. You can compare the beta strengths within a single regression table. So what we see here is that because age has a higher beta, we see that there's a stronger relationship between age and pregnancy risk than there is between exposure to sex on TV and pregnancy risk. However, you can see that both of these variables, both of these predictors, are statistically significant at the 0.001 level. So we can say that both a teenager's age as well as the amount of sex that they watch on TV are both positively associated with pregnancy risk. In terms of some differences, there are no absolute cutoffs for beta effect sizes as we have with the R cutoff. So we've previously learned that we had different guidelines, that the strength of a correlation is weak if it's 0.1, it's moderate if it's 0.3, and it's strong or large if it's 0.5. We don't have similar effect sizes for a beta, sometimes called a beta weight. The other thing that you might see in a regression table is something called an unstandardized regression coefficient. So a beta weight is a standardized statistic. It's a standardized coefficient. Much like the correlation, it can only range from -1 to 1. It's been standardized. But an unstandardized coefficient will tell you the amount that your outcome is expected to change or increase for every 1 unit change in your predictor. Okay? But what both will tell you, whether it's a standardized beta or an unstandardized regression coefficient, is whether there is a positive or a negative relationship between a predictor and an outcome, the strength of that relationship. Well, really a beta can give you that because it's standardized, and then whether or not it's statistically significant. All right. It's possible to control in a multiple regression analysis for many different variables. So thus far in the pregnancy risk and exposure to sexual TV content example, we just previously considered one possible third variable, which was age, but there's many others to consider. And so regression analysis helps answer 2 questions. One, it helps control for several third variables at once. And then second, it examines all the betas for all the other predictive variables to get a sense of which factors most strongly predict chance of pregnancy. Here we can see that a very strong predictor is being female. That has the largest, or one of the largest, beta weights here, and even one of the other variables are controlled for, being female would be one of the variables most strongly associated with pregnancy risk. All right, so when you're reading or hearing about association claims in a journal or in the popular media, especially in the popular media, you won't hear information about beta weight or criterion variables and so on. But you'll be able to determine whether a multiple regression has been conducted by paying attention to the language. So if you hear the phrase controlled for, or taking into account, or correcting for, or adjusting for, these phrases indicate that a multiple regression has been performed and that a relationship between one variable and another variable has been established, even taking into account many other possible variables. Okay, it's important to know that multiple regression is not able to rule out all kinds of third variables. So even if a researcher controls for a large number of variables, they can't control for everything. And so there are problems with making causal statements, such as more exposure to sexual TV content causes higher risks of pregnancy when a multiple regression has been done. The first is that a multiple regression can't establish temporal precedence. You need to have a longitudinal design to do that. So for example, you would need to somehow measure the amount of sexual TV content that teenagers watched in their early years and that at a later date were able to establish pregnancy risk. And then the second reason why it's very difficult to make causal statements, even with a multiple regression, is that it's nearly impossible to measure everything. And so there's often important third variables that simply weren't measured. All right. So we've discussed, or I've shared with you, how longitudinal designs can help establish temporal precedents, and then how multiple regression analyses can be used to help with internal validity by controlling some potential third variables. But there is another way that researchers can investigate causality, and this is called pattern and parsimony. And pattern and parsimony, it examines a variety of correlational studies that all point in the same causal direction. So when we're talking about parsimony, we're really talking about simplicity. And this is the degree to which a good scientific theory provides the simplest explanation of some phenomenon. Okay, so parsimony means that the simplest explanation is usually the best, and often cases, the correct one. So the idea of pattern and parsimony has been established with finding a link between cigarettes and cancer. And even though many of the studies have been correlational, well, there's actually been experiments with rats, but let's just say among humans, in which it's unethical to randomly assign people to smoke, all of the research have been correlational. And so here's some of the correlational studies or correlational findings. So the longer a person has smoked cigarettes, the greater the chances of getting cancer. People who stop smoking have lower rates of cancer than people who continue. Smokers' cancers tend to be in the lungs and of a particular type. Smokers who use filtered cigarettes have a somewhat lower rate of cancer than smokers of unfiltered cigarettes. People who live with smokers have higher rates of cancer because of passive exposure to the same chemicals, otherwise known as secondhand smoke. So what we have here is a clear pattern and a parsimonious, simple explanation: cigarettes cause cancer. Could any single one of these studies alone by itself have established that causal relationship? No. But the overall pattern, based on the accumulation of these studies, allows for the causal statement. So that's an example of being able to get at causality with using a pattern among many different studies, as well as coming up with the simplest, most parsimonious conclusion: cigarettes cause cancer. All right, moving on to a next topic in multivariate research, I want to discuss the concept of a mediator and the concept of mediation. So once a researcher has established a relationship between two variables, they often want to explore that relationship further by thinking about what is the reason why there is a relationship between two variables. So as one example, we know that conscientious people are more physically healthy than less conscientious people. But why? Okay, so we see the relationship, but why is that the case? The mediator, okay, which is a variable that explains or accounts for the relationship between a predictor and an outcome, the mediator between conscientiousness and being more physically healthy could be the fact that conscientious people are more likely to follow medical advice and instructions, okay? So therefore, they're more healthy. So the degree to which, or the likelihood of following medical advice, is a mediator of the relationship between conscientiousness and physical health. All right, now let's look at the example that I have on this slide. And this has been one that we've explored in a previous chapter. So we know that there's an association between having deep conversations, in other words, the amount of deep talk, and feelings of well-being. So researchers might propose a mediator for this relationship, which is quality of social ties. Well, how would it work? Deeper conversations might help build social connections, which in turn lead to increased feelings of well-being. So the way that this mediation relationship is drawn is in the figure shown on the slide. Okay. So the first thing to do would be to propose an overall relationship between amount of deep talk and well-being, which is symbolized with the path C. Okay. However, this overall relationship only exists because of the two other relationships. So the overall relationship C only exists because of the relationship between the amount of deep talk and quality of social ties, shown in the A path, and then the relationship between quality of social ties and well-being, shown in the B path. All right. So there could be other mediators, like growing more intellectually or taking a break from technology. It's possible in very complicated statistical designs to test multiple mediators of an overall relationship. But basically the way that it's done is to follow a couple different steps. And so if we want to know whether quality of social ties mediates the relationship between amount of deep talk and well-being, you'd look at a couple different relationships statistically. So the first thing is to look at this C path. You would need to establish covariance. You would need to establish that there's a correlation between the amount of deep talk and a person's well-being. The next thing that you would do is test for relationship A. So is there a relationship between the amount of deep talk that people have and the strength or the quality of their social ties? The next thing that you would do is test for path B. So do people who have stronger social ties also have higher levels of well-being? And the way to do this is to run a regression test using both strength of social ties as well as deep talk as a predictor of well-being. So in other words, you would do a multiple regression having both amount of deep talk as well as quality of social ties as two predictors. And then in doing that, you'd see whether this overall relationship disappears. So if strength of social ties is the mediator, the relationship between deep talk and well-being should disappear when the strength of social ties is controlled for in the multiple regression. And so you'd use that multiple regression tool. Okay. Now, it's important that doing this type of an analysis doesn't necessarily establish temporal precedence. In our mind, in our theory, we have this conceptual model where amount of deep talk is conceptualized as the predictor, as the thing that comes first, right? In our theoretical model, what we're saying is the amount that we engage in deep conversation, meaningful talks with people will strengthen the bond that we have with them. In other words, in the model, it's the deep talk is the thing that causes strengthening the social tie, which then causes well-being. But this direction could be reversed. It could be the case that that among our high quality friendships or social relationships, we engage in more deep talk, and that establishes our well-being. So this type of a mediator model doesn't necessarily get a temporal precedence. You still have to use a longitudinal design. Okay. So when you're reading research, you'll often see models that look like this, where there's clearly a causal model that is hypothesized, but just because you test a particular set of relationships using these multiple regression techniques, it doesn't mean that you've established temporal precedence. You really need to have a longitudinal research design in order to do that. All right, let's talk about the similarities and differences between mediators and third variables. So the similarities is that you'll find both in multivariate designs, and both can be detected using multiple regression. But there's differences as well. So in a third variable explanation, the proposed third variable is external to the two variables in the original bivariate correlation. So as we established with the example of age being a possible third variable for the amount of sexual TV watched and pregnancy risk, age was this problematic lurking third variable that was kind of outside of the relationship between the other two, and it potentially distracts from the relationship of interest. Okay. As another example, we could say that education level could be a third variable that is responsible for the relationship between deep talk and well-being. So what we're saying here is that deep talk and well-being are correlated with each other only because each one is correlated separately with education, okay, as shown in the figure here. So the relationship between deep talk and well-being is there only because both variables happen to vary with the outside third variable, education. So the third variable operates like a nuisance variable. It's not the thing that is of central interest to the researchers. They're really interested in deep talk and well-being, and so in that case, they would want to control for level of education to make sure that it doesn't get in the way. A mediator, on the other hand, is not a nuisance at all, and we can think of the mediator as being internal to the causal variable. So in the case of quality of social ties, that's kind of inside or internal to the relationship. That is the reason why we see the relationship between deep ties and deep talk and well-being is because of the kind of the link in the chain, is that deep talk causes one to form high quality social relationships, deep ties, which then causes well-being. Okay, another important distinction is between mediators and moderators. So we learned about moderator variables in chapter 8. So a mediator variable is going to ask, why are two variables linked? To mediate means to come in the middle. Okay, so think about a mediator kind of in the common English language is when people have a problem, they get a mediator to kind of get in between and solve the problem. So I think about that's one good way to think about how a statistical mediator operates. It gets in the middle. And that's a good thing in the statistical case. And that a mediator asks why. Why is there a relationship between what I'm thinking of as a predictor and what I'm thinking of as an outcome? So a mediator is the thing that is the explanation. It's the explanation for why I see a relationship between my predictor and my outcome. A moderator, on the other hand, asks the questions for whom or when. So it would ask, are these two variables linked in the same way for all participants or in every situation? Are there some situations in which we see a relationship between a predictor and an outcome, but there's other situations in which we don't? So to moderate means to make the relationship between two variables either more strong or less strong. Okay. So this figure, you can see, and this is in the textbook, of course, you can see the distinctions between mediation, moderation, and third variables, along with an explanation of how they're different. But again, with mediation, the key question is really, why are two variables related? With moderation, it's, are there certain groups or situations in which the two variables are more strongly related? And then with the third variable problem, it's that two variables are correlated, but only because they are both linked to a third variable. All right, so conducting multivariate correlational research, which could be a longitudinal design or it could be a multiple regression, this gets us closer to making causal claims. So what we've learned is that internal validity can help be established with a multivariable design. A longitudinal design can help establish temporal precedence, and a multiple regression helps rule out third variables. Okay, so in doing so and ruling out those third variables, a multiple regression can also help with internal validity. However, we don't want to forget the other three validities when interrogating multivariate designs. So in terms of construct validity, we've got all these variables now. And so for all of the variables in our multivariate design, we have to ask, are they measured in a reliable way? And are they valid measures of our psychological construct of interest? There's external validity. So we need to consider whether the results are generalizable to other people, other situations, and so forth. So we still want to look at how was our sample obtained? Was it a random sample? We learned with sampling that there's many convenience samples. There's many samples that are non-probability samples. So those are factors to consider when interrogating the external validity of a multivariate design. And then finally, there's the statistical validity. So we need to consider the statistical significance, that is the p-values, as well as the effect size of our beta weights. So you might have several betas that are statistically significant, in which case you can compare the effect size. So the short of it is that even though our multivariate designs help us establish internal validity, we don't want to forget about the other three, and we want to interrogate all four when thinking about the quality of the research that comes from a multivariate design.